Section 5.4, number 23. Jonalie has $1.65 in nickels, dimes, and quarters. If she has 4 more dimes than quarters and 1 more nickel than quarters, how many of each coin does she have? Again, this is going to be a coin problem, so I'm going to want to set up a chart so I can organize my information. We're going to start off with type of coin. The next column again will be number of coins. The next column will be the value of a single coin. And then the last column is always the total value coming from each type of coin. And if we look carefully, we're going to notice that there's 3 coins in this problem. So let's see if we can label that. We have nickels, dimes, and quarters. So now our chart has 3 rows instead of 2 like we've been used to. So let's make sure we separate those rows. And just like with any coin and ticket problem, I always make sure I fill in the value part first. It helps me gain my confidence. So nickels are worth 5 cents, dimes are worth 10 cents, and quarters are worth 25 cents. And the biggest battle of setting up the chart is coming up with the expressions to put in the number column. So because I have 3 types of coins, I have to be very careful who I call the single variable. I want to read this a little bit more carefully. If she has 4 more dimes than quarters and 1 more nickel than quarters, how many of each does she have? One thing I notice when I have 3 coins set up, a lot of times the problem will compare every single type of coin to one type of coin. So if you notice in the first sentence, she says, let's see, 4 more dimes than quarters. And the second part of the sentence, it said 1 more nickels than quarters. So I notice that they're comparing the number of nickels and the number of dimes to how many quarters we have. So because we don't know how many quarters we have, we could actually use, that one would be a good candidate for our single variable. So I'm going to call the number of quarters, I will use Q because it really helps me keep my variables in line. And then I'm going to use some translating from English to math. So when we say we have 4 more dimes than quarters, I'm going to highlight that for you, 4 more dimes than quarters, the more is going to imply that we're most likely going to use a plus sign. So if there's 4 more dimes than quarters, there should be more dimes than quarters. How many more? 4 more. So I believe I'm going to have a 4 plus Q for the number of dimes. And then nickels, it also says, we're looking at, again, 1 more nickel than quarters. The more would indicate that it's a plus sign. And how many more nickels than quarters? 1 more nickel than quarters. So again, I'm going to kind of mark that in my problem. I believe I'll be adding 1 more nickel than I have quarters. So now I believe I have the setup for number of coins for each of those. It's now time to fill in the last column, and then we will be able to get our equation. So if you remember correctly, we always multiply the number of coins times the value of a single coin to give us the total value. So the column should read, or the cell should read, 0.05 times 1 plus Q. It's going to tell us how much money we're having from the nickels. 0.10 times 4 plus Q. And 0.25 times Q. Once we have the total value column filled in, we're going to want to set up the equation. So the equation always works where we are taking the total value of the nickels, adding that to the total value from the dimes, and adding that to the total value of the quarters to get the total value that Jonah Lee has in her pocket or piggy bank. So that's going to be $1.65. So again, I'm going to look at my total value cells. So 0.05 times 1 plus Q plus 0.10 times 4 plus Q plus 0.25 Q to equal $1.65. Now we have our equation. Now that we have our equation written, we're going to get ready to solve it. And again, we always look back to our problem solving and equation solving strategies from chapter 4, where when I see an equation that has parentheses, I'm going to want to simplify each side separately. So I notice to do that, I'm going to want to use the distributive property in two places on this left side. So I'm going to have 0.05 times 1 is 0.05. 0.05 times Q is 0.05 times Q. I also have 0.10 times 4 is 0.40. And 0.10 times Q is 0.10 Q. Put that decimal point in there. We also want to carry down the 0.25 Q and the equal sign to $1.65. To finish off simplifying each side separately, we need to look at the left side and notice that we have like terms that we're going to want to combine. So I'm going to look at the variable parts first, 0.05 Q, 0.10 Q, and 0.25 Q. I'm going to add those together to get 0.40 Q. I'm also going to want to look at the constants, 0.05 and 0.4. Those will be added together to get 0.45. That's still equal to $1.65. So now the next step would be to move the constant over to the right side by subtracting 0.45 on both sides. So that will leave us with 0.40 Q to be $1.65 minus 45 cents will give us $1.20. Now, to finish off my equation, I want to divide both sides by 0.4. And that will leave me with Q equaling 3. So I remember I set up my variable to represent, Q represents the number of quarters. So I'll kind of summarize this information on the side. There should be 3 quarters. And I also have to remember that I had to come up with a number of coins for nickels and dimes. So I always want to check back to my chart to figure out what did I use for nickels, or go back to the information in your word problem. So with nickels, I believe they said there was one more nickel than quarters. So one more nickel than quarter would imply that that should be 4 nickels. And with dimes, they said there's 4 more dimes than quarters. So that would be 4 plus 3, which would give us 7. So our final result would give us 3 quarters, 4 nickels, and 7 dimes to total $1.65 in Jonah Lee's purse or pocket.